welcome to my talk about effective debugging of Kotlin native. Can you hear me okay? Yeah? All good, cool. So a little bit about me. I'm Tadeas Kriz. I'm a senior mobile developer at TouchLab. I've been doing KMP for quite a while, and before that I was doing iOS, and even before that I was doing Android. So I have a lot of experience between those platforms and can compare what's good at one of them, what's bad at the other one, and so on. I am also one of the authors of Sky. So if you don't use Sky yet and you use KMP, make sure to go and try it out. You'll thank me later, and your iOS developers will thank me even more so. So I'll leave it up for just a little bit. So I debated myself on how to structure this talk for a long time, actually. And then I decided we'll do just live debugging. And we'll go through an app that I've prepared, and it's a KMP app, so we'll debug it together and we'll learn in the process. However, at the last minute, I decided against it and redone the talk. It will still be basically live debugging, but it will be different. So why have this talk at all? Why are you here? If you use Kotlin native, show of hands who uses KMP. Okay, so you all basically use Kotlin native. It has certain debugging limitations, as you are aware. So I want to showcase those kind of and also talk about how you can overcome them. The reason basically is that Kotlin native to the debugger is seen as C89. So it's not seen as Kotlin, it's seen as C, right? And if you know C, you can compare the two and you know that C doesn't support all the things that Kotlin does. I also want to tell you about Xcode Kotlin, which if you don't have it installed, make sure to install it. And then we'll take a look at some interesting stuff that I think like you will not need it day to day, but when you need it, it's good to know it. So Xcode Kotlin, what it is, it's a plugin for Xcode where you can debug Kotlin and have some very basic syntax highlighting directly in Xcode. To install it, we run the brew install Xcode Kotlin, and for reasons I think are like straightforward, I'm not doing this live. And then you do Xcode Kotlin install, and that will install it. Whenever you install a new Xcode version, you should run Xcode Kotlin sync, which will make sure that it works in the new Kotlin version. So let's get into it. So as I mentioned, I've prepared an app on both Android and iOS. And I wanted to just go through the issues that I've baked in and debug them. However, because we don't have a lot of time, I made those issues super simple that debugging doesn't make sense. And when I was doing the rehearsal, I kind of found out that it doesn't make sense. It's more like confusing. Why are we debugging such a simple thing? So instead, I'll tell you how I approach debugging of issues with KMP, and then we'll look at comparison between Android Studio debugging of Android app and Xcode debugging an iOS app. And then we'll look under the hood into some hopefully interesting things. So we'll start here with the only tab that we will be using, which is this shared bug. It's rendering weird on my screen. Is it okay on your screen? Okay. So, very simple. We enter text to log each word on a new line. So we do hello world and then log, and it should be a new line. But there's a problem. There's a space left, which we don't want. We want just the words. So the way I would approach this when debugging KMP is I go to Android and I try to reproduce the issue on Android. So we go to Android. We have this shared tab here as well. We type hello world. And I already left some breakpoints in. Of course I did. So let me continue. And you can hopefully see, perfect, that we have the same problem. So there is the space. So we know that this is happening on both platforms, and that is beneficial to us because now we can debug it on Android. So we put the breakpoint in, we click the button again, cool, perfect, we can step in. It will do a bunch of stuff that I don't want to look at. So we'll just go in here, put a bunch of breakpoints in, and we step through. We see the frame variables here. So these are like the value, which is our parameter, or any local variables inside the function. So we jump through, see the result, what's happening, we're building it. I want to mention I would never write code like this in a regular Kotlin. This is all for example purposes. I don't want you to think of less of me. And so we would go through it and we would actually find that, yep, we are still adding the character here even when we don't want to. So we would put it here. And now we fix the issue. And if we remove these or just disable them, run it again now without the debug. Hopefully that won't take long. The issue is gone, we debugged it. But the good thing about KMP, as all of you know, if we now run the same app on iOS, we fixed it there as well. So, yay, benefits of KMP. So, let's take a look at the comparison of debugging in Android Studio and Xcode. So in both, we can put breakpoints on lines of code. That's kind of like makes sense, and it's the same everywhere. So I'll get rid of this real quick. So we have a little bit more space. So here we are in a Swift file. We can put breakpoints in. We don't really care about Swift right now. So we'll go and add Kotlin. So one thing that is a little weird is to debug the Kotlin, you need to add it, right? So we need to add it here into the project. You can add it anywhere in the project. It doesn't really matter. We go to add files and then find the sources in the shared, so shared source. We don't really care about the Android main or the common test, but it's better to include source and add it as a folder because that will mean that it will automatically update. If we add it as a group, which we'll see in a second, it would mean that every time there is a new file, we would need to manually add that in Xcode to see it. So we'll just add source. And here we need to make sure that we do reference files in place. So we don't want to copy the Kotlin files. We just reference files in place. The second thing here, groups. This is the create groups option. Do not choose that. Choose create folders. And then the last, probably the most important, please, uncheck this. If you don't uncheck that, it means you will be shipping all of your Kotlin sources that we've just added with your iOS app. So anyone who downloads the bundle can just unzip it and see all of your Kotlin sources. If you use KMP for just logging, that might not be a problem, but if you have all of your implementation in there, someone will not be happy. So let's add that, finish, and we can see it here. So we can go through and take a look. So what have we been looking at? So we've been here, text splitter. So we go to text splitter, and because I already installed the Xcode Kotlin plugin, you see the like really simple syntax highlight, but that means that we can add the breakpoints. So if we add breakpoints, not here, say here, and now I have put it here. So if we hit the log, we will stop here, as we would expect. So this is the same thing that we would have here on Android. Nothing really groundbreaking. We just stopped on a breakpoint. But for Kotlin native, it is a little groundbreaking because like Kotlin native still has a lot of limitations here. So let's actually stop there with Android as well. Is that oh yeah, my bad. Okay, so hello world, so we have the same input, and not this one, skip. So now we are at the same point in our Xcode and then our Android Studio. So we can take a look at the frame variables here. So in Android Studio, we see the value, we see hello world, and then here we, on the right side, on the bottom right, we can switch between the frame view and our console. So let's open the frame view, it will load, and you can already see one weirdness. We see all of the things. So in Android, we only see value because everything else is coming later. But that's not the case in Xcode. So in Xcode, we see everything with things that don't make sense. That they are not initialized yet. That memory is not initialized yet. So the only thing that is initialized here is value. One thing that I hope everyone here knows, but I'm gonna do a quick show of hands. Does everyone know how to run expressions for each breakpoint? Okay, cool. So basically, in this, it works the same way in Xcode as in Android Studio. So we right click, and then we can do more and evaluate and log. And here we can say just log character. Done. So if we do that, it means that every time it will stop at this breakpoint, it will evaluate the character. The same as I mentioned here, we can, let's see, this one here, edit breakpoint. And here we can go and add an action. So add action. And it's the debugger command. So in Android Studio, it was directly the expression we want to run. Here it's actually running a debugger command, so we need to give it the command that we want to run. I'll skip ahead a little bit and we'll just use PO. I'll tell you what the PO is in a second. So we'll use PO and character. And the last thing we want to do really is automatically continue after evaluating actions so that we don't stop there, we just evaluate. So we do that and run. And we don't want this one, we will want this one. Keep running, and you can see all of these nice numbers. They're supposed to be characters though, right? So that's another issue you have with Kotlin Native is sometimes we don't really know, because the information is presented to you by the Xcode Kotlin plugin. But sometimes it doesn't know what the type really is. In this case, the type really is, I think, just short. So if we stop here and rerun, the character is actually a short. How many of you have ever written C? Okay. So you probably know that if we have a short, we can just do a cast and we get the letter. So now we can just go and edit. And because this is the same thing that we just ran, we can just cast it here. And it will work, considering I removed this one. So now we see what we needed to see. So what I do recommend here is usually I just run the expression directly in the command. And then when I see the result I'm expecting to see, only then I go and add it to the breakpoint. So other things with breakpoints, we can add breakpoints for exceptions. We can add breakpoints for methods. The same thing, again, works in Xcode, but you won't be, at least I don't think so, you won't be able to add breakpoints for exceptions of Kotlin unless they are crashing the app, but at that point it's too late. But you can do Swift errors and Objective-C exceptions. To do that, we go to this tab, which is the breakpoints, and we will remove all the breakpoints so we have nothing in our way. And if we hit plus, we can choose what we want. So we can do Swift error breakpoint, exception, symbolic breakpoint, and so on. One of the breakpoints that is the most used by myself, at least, is the symbolic one. Symbolic breakpoint allows us to tell Xcode a name, or LLDB, a name of a symbol that we want to stop at. And a symbol is a function, essentially. It's other things, but for our purposes, it's a function. How to find the symbol names, that's a different matter, and we'll get to it in a second. So if we had a function here, Basically, we would just do split by words, edit, put it here, and if this was the right name for the symbol, which, spoiler alert, it's not, it would just stop when we run the function. So the same way when you add a breakpoint for a method in Android Studio, where in Android Studio you just do this. That's a little more straightforward, but this is what we have to work with. Another thing I wanted to show you is how stepping works. Because you would just expect that stepping through the code just works, right? So here, oh, what? Okay, I don't know what I did. If anyone knows, let me know. So here we can just, and I closed it, of course. We can step through, maybe. Oh, the joy of live demos. Okay, let's restart that real quick. In Xcode, it's a little more complicated. But we will need the Android to run because of reasons. So here we go, we write something and log. So we stop here and then we want to step through. So we step over, and now we have a for loop. Step over and we expect to step into it, right? It's a for each is an inline function, so we want to go into it, and that's what we all expect, and that's what it does. So we keep stepping and we keep going through the loop until we get out. And we can also do step out to get somewhere, to get where we want to go. So this kind of works like you would expect. Not so in Xcode. So in Xcode, oh, okay. Side note, if you use Sky, that symbol that we've added actually does exist because it's a global function, and Sky adds all your global functions directly into the global scope, so you can call them. Which also means that it creates those symbols. So even though the Kotlin ones are not named like the function name, the one that Sky adds is actually, and so it stopped there. So that's good to know. We want to remove that. We don't care about it, really. We just care about this one. So we stop here. Let's do the stepping. So we step over, step over. I want to do step over, but then I'll have to go back to the simulator and rerun it to get back. So I'll spoil it for you. If I go and step over now, it will just jump to the return result. Because from the point of Xcode, the next line is the return result. It's not the for each. The for each is actually a function that we need to step into. I guess this works. This is very debuggable, right? You all understand, I think. Everyone took like the mastery of assembly course. Anyway, this is what like makes it real difficult to debug these things. And what you really need to do, unfortunately, even though you can step through to get there, it's oftentimes like goes through a lot of things that you don't know what they are doing, and it just makes everything more difficult. So you just put a breakpoint in, and then you, instead of stepping over or stepping into, you just continue. So like the kind of advice I give everyone, do not use the step over and step into. Just put breakpoints everywhere you think you would need to stop and use the continue. With Kotlin native, that's usually the best way to debug stuff. All right, so we have done this. Perfect. Let's get rid of these, and let's get rid of all of these. In Android Studio, when we stop anywhere and we stop here, we can use this evaluate expression to evaluate any Kotlin code. And if that doesn't work, which it often doesn't for, again, reasons, we can switch to Java and call even Kotlin code from Java, and the Java expressions usually work because it's an old language and it just works. We can also add watches if I can create one. So we can say character that doesn't exist, but if we stop here, we'll be able to see the character right away. The good thing is that this is actually possible in Xcode too. So we're actually already sending there. And we have the character, right? So we have the number, but we don't want it to be a number. One way to do that is we can change how the value should be viewed. So we can say, please, this is a character. And now we see a character, which looks weird. The other way, we can add expression, and we can say, cast character to char, and then done. And that actually looks better because it's showing just the character. And if we keep running, we will see all of it. Need to remove those. So, but let's back up to the expressions. Can we do expressions in Xcode? The answer is kind of, but mostly no. Mostly no in the context of Kotlin. Because as I mentioned, Kotlin is viewed as C. So even though we can run expressions, those will be C expressions, not Kotlin expressions. So if I wrote PO, which we used before for expression, and said, let's create a mutable list of, it will scream at me. It will scream at you different things. Sometimes you can actually hit something that exists, and then it might be like, oh, it's actually maybe working. It never works. So what can we do? First, I want to tell you about what are those commands that I've been using. So I've been using the PO so far. The PO is actually just an alias for vim print object description and something. So if we do result, no, we don't have result, we have value. This should be the same as this, which it is. I have to say that I love the name of this command, the DWIM, which means do what I mean. And I definitely wanted to see the address, not the value. Who would want to see the value? So we also have P, which is very useful, way more useful. And that's just vim print value. So these are the same thing. I'm telling you that because sometimes you see just the vim print somewhere and it's like, okay, what is it? Or you can see like an error or a warning about vim print, but you ran P, so what's up? So what do? We can use this thing called frame variable, which will give us the same thing. But this time, it's actually not running an expression. It's just giving us the value of that variable. The weird thing is, which I did not prepare beforehand, is that we should be seeing the value of value, and I don't know why we're not. Honestly, like this should be just show. Oh, I know. Okay, the reason is I've put in an empty string because I thought that I would make things easier for myself, and so an empty string, it seems, doesn't get rendered the right way, and that's a bug in Xcode Kotlin. If anyone reports it, I will gladly fix it, maybe, if it's possible. Anyway, let's skip this. Let's go back here and let's actually write something. So now we see hello here. And look, we have the value, no longer the address. So I need to kind of say sorry, Xcode, but not sorry. You guys have a low bar. Anyway, why I mentioned the frame variable versus the vim print or expression and P and PO, the reason is that frame variable basically works every time. Even if the frame is broken, which oftentimes is, the FRV will just work and will just give you the value. So usually you should see those values here. sometimes there might be a bug, it may not work, but the frame variable or its alias frv or its alias v, sure, let's have many of them, will give us that value that we want. Last command here that is useful in very narrow amount of uses, but when you need it, it is really useful, is reading registers. So we can do register read, and it will give us the values of all of the registers that are available in our frame. Now, this may seem useless, and it is. When you need it, it's usually when you need to go and debug something that looks like this. So when you're actually debugging in assembly, because sometimes you will have to, you can see the values of those registers at that point. And oftentimes it's just an address, because it doesn't know what's at the address. But if you do know, if you can figure it out from the assembly or from the expectation of what should be there, you can ask it, you can call it, you can do stuff with it. But right here, we don't really care. We have just wanted to show you like all of that information is there for you if you need it, and you can access it. So let's switch back to something that we can actually read. Perfect. Have you got, or I'll ask you a different way. How many of you use or have heard about Hopper disassembler? Okay. So this may be enlightening. I've already opened the code here, so we don't have to wait. I'm gonna delete this one. So when you're doing Kotlin native, usually, most of the times, you will not need this. But again, if you're doing a lot of Kotlin native, and I mean Kotlin multi-platform, there will be times where you need to actually call something in Kotlin when you're stopped at a breakpoint. Normally, you can do that because, as I mentioned, it's C89. Good luck calling functions in Kotlin. But there is a way. We just need to know what we need to call. Because we're in C world, we can do anything. So let's do one thing real quick. One of the examples that I have prepared is, let's see here. I need to go all the way here. Is this, I call it a native bug, and we are stopped. Yep, we are stopped. So here we have this simple unit conversion tool where we say, okay, how many things are in what? So how many metric cups are in one cup? Don't ask me what a cup is and how it's different from metric cup. I don't know. But what I do want to know is how many bushels are in a single megaliter. And I don't think that's one. Megaliter sounds like a big thing and bushel sounds like a small thing. So we went to debug this. We would learn that we are actually calling a Kotlin function. So I'm gonna stop here to show you how bad the stepping actually is. So we're gonna stop here in our convert volume. We want to go into it. So we go in. This will take a while. Okay, so now we got to the code that Sky generated for us for the global function. We don't really care. And then we can go in, which we cannot because Sky actually does another thing, which is enums. So it automatically bridges enums for us. But that's code that we need to execute. So when we're debugging and when we're stepping, it's something we need to step into, each and every single one. So as I mentioned before, let's just find the file that we're actually gonna be calling and put a breakpoint there. So let's skip all of that. Put the breakpoint where you actually want to stop. Do not step over, do not step into. It's too much hassle. So here we create NS measurement, which is a built-in iOS NS foundation thing, where we can give it a value, give it a unit, and then let it convert to a different value. So when we would be debugging this, we would probably want to see the inputs of this function, which we can see in the frame window, which we see 1 megaliter from megaliters to bushels. So that's expected. The problem has to be somewhere else. So let's just jump to this line here. What we'll find is one of the other bugs in Xcode Kotlin is it doesn't show you information about Objective-C instances. And the reason for that is whenever you're using Objective-C classes in Kotlin, you're not actually using Objective-C classes in Kotlin. You're using references to Objective-C classes. So to actually get the Objective-C instance, we need to somehow unwrap it. And for that, there is a function. We need to go to the hopper. I'm gonna move this here and move this here so it's easier. Whenever I need to find something, a symbol that I need when I'm debugging, usually I try to find something that sounds like what I want to do. So we have a reference and we need to get the Objective-C one. So let's just do ref and then maybe to objc. And that is here. That is indeed here. I now realize that I haven't shown you what I opened in Hopper disassembler. So a quick intermission while we do that. Well, open a new window, and then what we want to do is go into Xcode, go into settings, and you'll see locations tab. In locations tab, there's derived data, and we want to click on this tiny little arrow. That will open Finder or something similar to Finder. And we want to find our app here, which in our case is this one. We go in, we go into build, products. We're building it for simulator. And then we finally go to the app that we've built. I'm using a shared static library. So everything is built into that app. If you are using dynamic Kotlin framework, it will be a separate thing. It will be like this shared.framework, which will have its own binary in itself. And that's what you would want to open in your case. In our case, we want to open the actual binary here, which something I found yesterday, they changed. Usually it would be in this, like the main binary, but now there's can-debugging.debug.dylib. Something I'll need to, look into, but not today. So we go and put that into Hopper. So I'm dragging it into Hopper, just put it in. Usually, you don't need to change anything here. It will just load everything correctly. If you have, again, a dynamic framework and you have multiple architectures in, it will give you an option to load either ARM64 or X64, the Intel one. It doesn't matter. Nobody uses that anymore. So you go, OK. And it will take a while to load, which we will skip because we have it already opened here. Back to our ref to objc. So this is the symbol, and symbol can be anything in native, but for us, this is a function. So we need to copy the name, because we will need it. Come on. And if we want to know what it actually does, all we have to do is read this assembly code. But actually, there's something better. We can disassemble into C code, which is a little bit more readable for this function. But if we're actually looking for, let's say, the convert volume, which should be this one, I guess I'm just going to go and read the assembly instead at this point. So the thing is, now we have the symbol name. So we probably know what we want to run. But how do we know how to do it? If we just go and say expression and just run it and say, actually, are we stopped? Yes, we are stopped. We have measurement. So we say measurement. This will not work because we don't have a header file loaded in the LLDB that would know about this function. So the symbol doesn't exist, even if we remove the underscore, which shouldn't be there. So it doesn't exist. We need to find it. And to find it, we can use a different LLDB command, which is called image lookup. So image lookup allows us to go through all of the symbols in the current runtime and find the one that we're looking for and where it is. So we will use -r, which is use regex, so we don't have to have it correctly. And then we use -s, I believe, and the name of the symbol. If I remember correctly, the underscore in front is only in Hopper and shouldn't be here, so I'm not including it. And if I've done everything right, we will see the symbol. However, this still doesn't have enough information for us, and we need to do one more thing, which is run in verbose. So we -v, run it again. It takes a while. The larger your app, the longer this will run. But then we get this range for this symbol here, and we can copy it, and we can go do expression and just use it. Except we can't, because it's just a number. We can't really call a number. So we need to kind of find, how do we make a number into a function? Well, it's C, so the syntax sucks. So let's do a cast. So that's these parentheses. And what we will be returning is a pointer. We can either do a void pointer, or we can actually use ID if we were in Objective-C runtime, which we are not. So we will use void pointer. And then normally you would name the function here, but we are just casting. So we will do this, because why not? And then we need the parameters. And the parameters in our case will just be another void pointer, because everything is a void pointer. So now, if we actually put this into parentheses, we got DNS measurement. So we got the original Objective-C class. And as you can see, it's as useful as I have nothing. As me? Too much? So what do we want to do? Usually is use this cast to create a reference to that function. So now we have this $1 assigned in the debugger, and we can use it as a reference. We no longer need to do the casting. We just can do $1. And you can also see that it actually knows this is the function that we are looking for. So now we can use another nice trick, which is running in a different language. So the expr, the expression command, allows us to supply -l and then the name of a language. So let's do Objective-C. Everyone knows how to write Objective-C, right? So we have $1, we give it the measurement, and we can do description. Except we can't, because it's a void pointer. And Objective-C doesn't deal with no void pointers. So we need to go in here and do ns measurement, which is the class that we've seen that we were using. It's a pointer. And now we finally arrived at getting a description. So through all of this, we got a very simple toString. So I hope you appreciate how Kotlin native makes things easier, because we can share code, but also way more difficult whenever you're doing any kind of debugging. Lastly, if we have time, we don't have much time, so we'll skip for questions, because the last thing would be very weird and it may not work and it will probably just crash the app. So I'll save myself the embarrassment and we'll go right to questions. Well, closing. Make sure to install Xcode Kotlin. Consider trying Hopper disassembler whenever you need to do. Oh, you don't need Hopper disassembler. All of this stuff is like, you can do it without that tool. It's just way simpler when you can just search through it and go through like the disassembled code. You can use nm, which will give you all the symbols in a binary. So in your terminal, you can do nm and the name of like the path to that binary. It will tell you all the symbols, so you can search for them that way. It's just clunky. And yeah, have fun with debugging. A lot of patience. And now we will open to the questions.